Good afternoon, everyone. My name is Alexandre Valentin Jamet, and I'm currently a second-year PhD student in the Barcelona Supercomputing Center. During this presentation, I will be presenting our work on the characterization of the impact of cache replacement policies on big data workloads. As we said in the previous slide, replacement policies are answering the question, how far in the future would that block be useful? Replacement policy is a thoroughly studied and explored topic. When it comes to the well-known SPEC CPU 2006 and 2017 workload. However, when it comes to new workloads, gap, XSBench, and so on, that exhibit poor temporal and spatial locality, we showed that state-of-the-art replacement policies are helpless. The methodology used to obtain this figure is the same as reported in slide 26. As we can see, gap and XSBench with LLC MPKI of 78 and 37 are much more intensive than SPEC. One can also see that when we are talking about speedup over LRU, state-of-the-art last level cache replacement policy incrementally improve over time for SPEC workloads. However, we observe that these policies struggle at generalizing to other workloads. When it comes to LLC and PKI results, we only show the 50 most intensive workloads using the LRU policy. All workloads shown on the figure exhibit a much higher LLC and PKI compared to the previous works with an average of 120. On the speedup results and dealing only with state-of-the-art replacement policies, it turns out Multiperspective is more versatile than Glider and is able to deliver good performance even facing very complex workloads. As a matter of fact, Glider gives a geometric mean speedup of 5% while Multiperspective goes up to 7%. This shows the need to include more workloads in the training of these replacement policies to allow them to generalize to different behaviors. When extending results to the two proposed designs, we see that their ability to change the features used to build predictions depending on the phase of workloads they are facing allow them to deliver higher performance improvement with a geometric mean speedup over LRU of 8% for DS-MPPPB and 8.3% speedup for MS-MPPPB. It turns out Cron and Niren are two graphs with either a high average degree or a highly skewed distribution. These two characteristics tend to make access patterns even more irregular and lower cache utilization.